Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from 2018. This is paper 2 and we're on question 19. This is a question about volumes of solids and in particular volumes of spheres. So what we're given is this equation, which is the volume of a sphere is equal to 4/3 of pi r cubed, and also that the surface area of a sphere is 4 pi r squared. And what we've got here is 1/4 of a solid sphere. So it's been split into 4 parts. And we've got to find the surface area of this shape, given that the volume of the shape is 576 pi centimeters cubed. So we can say, if we're applying this formula, that what we've got is 1/4 of a sphere. And so since the formula for the volume of a sphere is 4/3 pi r cubed, we can say 1/4 of 4/3 pi r cubed is equal to 576 pi, as it's given there, the volume 576 pi. And the first thing that we could try and do from this is actually find the radius of this quarter sphere. So we can tidy this up first of all. We can say, well, if we take 1/4 there, that 4 on the bottom is going to cancel with a 4 in the numerator. And then also, if we was to divide both sides by pi, then pi would disappear there and disappear there. So what we'll be left with is r cubed over 3 is equal to 576. And then if we multiply both sides by the 3, so times both sides by 3, the 3 is going to disappear on the left-hand side, and it's going to leave us with r cubed is equal to 1,728. So we don't want r cubed, we actually want r. So we need to find a way to get rid of the cube on here. And the way we do that is the opposite to cubing something is to take the cube root. So I'm going to cube root this side, and I'm going to cube root this side, which is doing the same thing to both sides of an equation, which is what we need to do. And if I cube root r cubed, I actually just get r. And then if I cube root 1,728, put that in my calculator, what I will get is the cube root is 12. And what that means is 12 times 12 times 12 would give us this 1,728. So we found the radius, and from that we can now attempt to find what the surface area is. So we're going to use this formula, and we're going to say, right, well, the curved bit on here, the curved surface area, so curved surface area, I'll just abbreviate that, is actually 1/4 of the surface of a sphere. So curved surface area is 1/4 times 4 pi r squared. And then we've also, as well as having this curved surface bit, we've got these other areas, which are the flat surfaces, which we've got from cutting the sphere into 4 parts. And we could imagine folding that along this line, and what we would get is we would get a circle, and that circle would have a radius as for the sphere would still be radius r, and the area of this circle is pi r squared. So what we'll be doing to get the total surface area of this shape is we would be adding this bit and this bit together. So if we do that, total surface area is going to be 1/4 of 4 pi r squared plus the pi r squared from the inside bit, which turns out to be a circle. If we cancel the 4 there with the 4 on the top line, we just get pi r squared. So we just left with that pi r squared plus another pi r squared, So that's actually equal to 2 pi r squared. So we're nearly there, and what we can then use is the fact that we worked out that the radius of the original sphere from this volume formula was 12. So we're going to substitute this 12 into the surface area formula. So we're going to get 2 times 12, 2 pi times 12 squared. 12 squared is 144, so we end up with 2 pi times 144. Multiply 2 and the 144 together, we get 288 times pi. And if we put that into the calculator, what we'll end up with is 904.7786 and a lot more decimal places than that. But what we're asked to do is find it to 3 significant figures. So 3 significant figures means it's going to be cut off there because we've got 1, 2, 3 places there. And we're going to decide that because the 4th place here is a 7, we're actually going to add 1 to the 4, and we're going to get that it's equal to 905, and it's going to be, because it's surface area, and we're working in centimetres cubed, this is going to be centimetres squared, because we need to be consistent with our units. So that was centimetres cubed, what we said the volume was, so this is going to be centimetres squared for the area. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, which is Gary Teaches Maths. And for more help, you could visit our website, which should be appearing at the top of the screen now, which is bestmathstutors.co.uk. Thanks for watching.